mass spectrometry can be used as a detection method in a gas chromatographer or a high-performance liquid chromatography equipment, and that's what we call GCMS, gas chromatography mass spectrometry, or HPLC-MS if it's a high-performance liquid chromatography equipment that you're combining with your mass spectrometer. How does a gas chromatographer works? Well, a gas chromatographer uses a mobile phase, which is a gas, a carrier gas, nitrogen or helium, that is injected into a column that is kept in an oven, and it runs continuously. The sample is then injected, or automatically or using or manually, and is vaporized in the entry point. The vaporized sample is carried by the mobile phase through the column which is sitting in the oven. And if your sample is a mixture of compounds, the different compounds will travel at different speeds through the column and will come out of the column at different times. And you can play with the conditions of the oven, the temperature of the experiment, to get the different compounds in your mixture to separate. And finally they are detected and you get a chromatogram. And if this detector is a mass spectrometer, is when you have GCMS, gas chromatography mass spectrometry. Gas chromatography is a very useful separation and identification technique. You really need very small amount of sample, and it can be very useful for volatile compounds. You need to be able to vaporize your sample. You can't do GCM, which sort of precludes water-based samples. Not completely. You can use GCMS for water samples, but it's not as straightforward as if you have a non-water based sample, which is very volatile. So it works great for many applications in which you are working with volatile compounds. The technique is destructive. You are volatilizing the sample, so it's destroyed in analysis. For those of you that have never seen one, this is how a chromatogram looks like. You measure what we call the retention time, which is the time that it has taken for the different components of the sample to come out with respect to how fast the solvent in which that sample was diluted comes out. And it can give you qualitative information. You know, the different peaks in this chromatogram may be a 0%, 3 different compounds, and it can also give you quantitative information, because the area under the peaks is proportional to the concentration of those compounds. So with an appropriate calibration curve, you're able to identify not only the compounds that you have in your sample, but also the concentration. In GCMS, the detector is a mass spectrometer. So for each compound that leaves the column, for each of these peaks in your chromatogram, the equipment records a mass spectrum for that particular peak, which represents one compound. So you have a collection of mass spectra that then can be compared with databases, for example, and you can find the identity of the compound. GCMS is widely used in the food industry, in chemistry. It's used in the forensic context. For example, in arson investigations, it's very useful to identify accelerants. In environmental analysis, it has a huge range of applications.